November 1944, deep within the choked, muddy, and perpetually shadowed expanse of the Hürtgen Forest, the industrial contest of the Second World War reached its most brutal and uncompromising phase. It was not a grand strategy playing out on a map, nor a clash of singular heroic wills, but an unforgiving trial by attrition, where every cubic centimeter of mud and every shattered pine tree became testament to the mathematics of destruction. Here, in the indifferent freezing rain, stood the object lesson for the German High Command, though they were too proud, too consumed by their own technical mythology, to recognize the terrifying truth of its existence. A burned-out M-Four Sherman tank, universally known by the surviving crews as the Bastard. The wreck was more than just a casualty. It was a mechanical cadaver, rendered obsolete by a perfectly placed projectile from a long-barreled German Panther, a machine of sublime, if scarce, engineering. The 88mm impact had reduced the Sherman's right track bogie to a twisted bouquet of shrapnel, jammed the 75mm main gun in a permanent droop, and scorched the massive Continental radial engine into a useless block of carbonized aluminum and steel. For the American motor pool, the decision was instantaneous, driven by the simple, overwhelming confidence of the most productive industrial power the world had ever known. The tank was Class 5, a total write-off, a resource so abundant it was declared expendable, to be bulldozed into a temporary ditch and replaced within 72 hours by an identical, factory-fresh twin shipped straight from Detroit. The German sentiment regarding this technical philosophy, the mass-produced mediocrity, the lack of elegant complex armor, the very notion of a machine treated as disposable, was encapsulated by a piece of black chalk, likely wielded by a laughing Panzer grenadier during a brief, blood-soaked counterattack. Scrawled across the Sherman's thick, soot-stained glacis plate, a perfect mocking challenge, Zurück zum Ford-Werk, return to the Ford factory. This single, sardonic line, meant to represent the ultimate insult, was in fact the unintentional distillation of America's terrifying advantage. Yet one man stood against the casual doctrine of abundance, seemingly defying the very industrial logic that had birthed his country's war effort. Master Sergeant Earl Pappy Jensen was a man built not for grand campaigns, but for the unforgiving specificity of the internal combustion engine. He was introduced to the wreck not by an order, but by an intuitive, visceral refusal to concede even this single ruin to the enemy. Jensen saw not scrap, but a collection of reusable components, not a failure, but a temporary disruption in the supply chain of violence. For the rest of the motor pool, the salvage operation was a Sisyphean effort, a counterintuitive act of misplaced loyalty. Why salvage a single broken tool when the entire foundry stood ready to send 1,000 more? The conventional wisdom, the logical resource management choice, was clear: abandon and replace. But Jensen, a technician possessed of the deep, stubborn ingenuity born of the American heartland, understood the deeper rhetorical importance of the task. He understood that the war was not ultimately won by the quality of the first shot fired, but by the quantity of the last tank left standing. The German military's faith was placed in the ideal machine, the Tiger, the Panther, vehicles whose perfection demanded scarcity, whose production lines were brittle, centralized, and slow, relying on highly specialized components and artisanal labor. This technical perfection was a beautiful, devastating, but ultimately suicidal strategy, predicated on winning every local engagement with a firepower differential that could compensate for their limited numbers. Their strategy demanded that a single Panther should be able to destroy 10 Shermans, thus balancing the scales. The American response, embodied by the maligned M-Four Sherman, was diametrically opposed. The M-Four was designed not for singular glory, but for mass production, ease of repair, and, critically, component interchangeability. Its entire existence was the rejection of technical hubris. The core thesis of the conflict was now laid bare in the mud of the Hürtgen. The German military demanded scarcity, banking on quality. The American military embraced abundance, knowing that quantity itself was the most devastating quality. The true battlefront was not the thin line of mud and blood, but the profound difference in production philosophy, where every single American-made part, every bolt, every weld, and every simplified design choice was an act of industrial supremacy. Jensen's refusal to abandon the bastard, his grim determination to wrench 3 dead tanks into one living monster, was a microcosm of this strategy, a stubborn physical declaration that the United States had so many resources, such an overwhelming capacity for steel and oil, that it would not even surrender a piece of burnt scrap to the mathematics of defeat. The German war machine, a breathtaking testament to engineering philosophy, was constructed upon the faith that quality, when sufficiently advanced, could negate any disadvantage in scale. They sought the perfect weapon, the Tiger tank, the Panther, the Messerschmitt. Me-262 jet fighter, each component meticulously calculated, often handcrafted, and complex to the point of structural fragility. Their obsession was with the density of the machine, the thickness of the armor, the length of the cannon, believing that a single superior unit could shatter 10 inferior ones, thus balancing the mathematics of defeat that loomed so large across the Atlantic. This belief manifested in their manufacturing core, relying heavily on a singular sophisticated power plant like the Maybach HL-230 engine, a complex high-performance apparatus which demanded specialized technicians, scarce materials, and long, centralized assembly times, making every single unit a precious, almost irreplaceable artifact. This was the ideology of scarcity, the brilliant, beautiful engineering of a besieged fortress, ultimately designed to be brittle under stress because it was never intended to be mass-produced. The American reply was not elegance, but avalanche, not technical poetry, but industrial scripture. It was the uncompromising doctrine that quantity was the ultimate quality, a belief system cemented by the astronomical figures of raw output and component standardization. Consider the Sherman's engine, the Continental R975 Radial, a power plant originally designed for aircraft, standardized, simple, and capable of being swapped out by 2 mechanics in under 3 hours. Its components interchangeable across a vast network of decentralized factories, often manufactured by companies that, just months prior, had been producing farm tractors or refrigerators. This philosophy of interchangeability was the true weapon. Where a crippled German Panther might sit for weeks awaiting a single, specialized component, the Sherman was dragged back to a triage point and immediately given a complete, factory-fresh limb from an inexhaustible supply. The sheer difference in scale between these two paradigms was, quite simply, insurmountable. In 1943, German steel production peaked at around 25 million tons. In that same year, the United States produced 63 million tons, an overwhelming tide of raw material that fed not just tanks, but the entire logistical superstructure of war. The physical embodiment of this colossus was the Ford Willow Run plant outside Detroit, a 4 million square foot cathedral of assembly where the B-24 Liberator bomber was constructed. This was no artisanal workshop. This was the brutal realization of Henry Ford's vision of continuous flow, turning specialized engineering into assembly line repetition. At its operational zenith, Willow Run was producing one 4-engine heavy bomber every 63 minutes, a rate that dwarfed the entire monthly output of the German Luftwaffe. The contrast extended across the oceans. While German U-boats desperately attempted to throttle the flow, American shipyards launched over 2,000 Liberty ships, utilitarian cargo vessels that could be built from keel laying to launch in an average of 42 days, guaranteeing that for every 2 German ships sunk, 5 American replacements were already crossing the Atlantic, laden with enough steel and grain to wage a century of conflict. But the most unforgiving metric The absolute determinant of the war's trajectory was petroleum. The German war effort, starved of natural reserves, was predicated on the laborious, resource-intensive synthesis of fuel from coal through the Fischer-Tropsch process, a critical dependence that turned a handful of refineries into the most vulnerable existential targets on the continent. Every gallon was rationed, hoarded, and fought over. A German general staff officer might spend days coordinating the transport of a meager 300 gallons of high-octane gasoline just to fuel a tactical reconnaissance mission. The Americans, by contrast, operated in a state of almost criminal abundance, drawing effortlessly upon the boundless reserves of Texas and Oklahoma. This excess allowed for military behaviors that must have seemed like outright madness to the German command. Fighter escorts were allowed to loiter freely, burning fuel prodigiously. Bomber sorties consumed thousands of gallons per hour. And the logistical tails stretched for hundreds of miles, constantly moving, consuming fuel with an unapologetic veracity. This was the mathematics of consumption, where the American military was unburdened by logistical restraint, able to execute tactical decisions based purely on the immediate objective, while the German Wehrmacht was constantly tethered to the shrinking, desperate reserves. The German supply line was a brittle, winding, and easily severed artery. The American line was a constantly replenishing, inexhaustible river of steel and oil. And the man rebuilding the bastard in the Hürtgen knew, instinctively, that the only true difference between his wrecked tank and a new one was simply a matter of when the next shipment from the great industrial colossus would arrive. Back in the endless, unforgiving deluge of the Hürtgen, with the German chalk marks still mocking the wreck's uselessness, Master Sergeant Earl Jensen began his grim, intimate struggle. His task was not one of battlefield heroism, but of pure, stubborn engineering defiance. He was an individual fighting against the inertia of both nature and regulation, a lone technician standing athwart the tidal flow of American abundance and screaming, "Stop! This one is not yet dead." The M-Four Bastard was classified a Class 5 hull, a category reserved for total material loss. Yet Jensen saw only 3 discrete, catastrophic failures that demanded not replacement, but radical, unauthorized surgery. According to the meticulously printed field maintenance manuals, 3 components, the engine block, the 75mm main armament, and the final drive differential, were irreplaceable in the field, necessitating a return to a depot-level maintenance facility or outright scrapping. The American supply doctrine, underpinned by the confidence of overwhelming industrial capacity, stated that it was simply cheaper, faster, and logistically simpler to send a fresh tank than to repair these primary structural units. Jensen, however, was operating on a different, deeper principle, the moral mandate of the machine. His initial enemy was the massive 9-cylinder Continental R975 radial engine. The German, the shell had not directly penetrated the engine compartment, but the shock wave and subsequent fire had fused key components and warped the block's integrity. The oil sump was shattered, the magnetos were destroyed, and the crankcase was compromised. The book answer was to remove the entire assembly and replace it with a new crate engine. The Jensen answer, performed in the freezing ankle-deep mud under a tattered canvas tarp, was to violate the maintenance protocol entirely. He scavenged a usable crankcase from a nearby M10 tank destroyer wreck, a vehicle that used the same power plant, though its components were never meant to be interchanged in the field. Using a borrowed hand-cranked boring bar, meant only for minor cylinder scoring, he spent 2 days reboring the slightly out-of-round cylinders of the original block, a process that demanded a micrometer's precision in an environment optimized for blunt force. His goal was not factory perfection, but functional viability. He traded longevity for immediate readiness, making a calculated bet on the mathematics of tenacity. The second critical failure was the 75mm M3 main gun, its recoil mechanism permanently jammed by the sheer force of the near miss. To dismantle the massive breach in the field was deemed impossible, yet Jensen, using a jerry-rigged pulley system attached to a salvaged towing cable, carefully extracted the barrel and its shattered cradle. He then performed the unthinkable, mating the intact barrel and recoil sleigh from a second ruined Sherman, a machine that had thrown a track and been burned by its crew, to the bastard's turret ring. This was unauthorized cross-pollination, an act of mechanical heresy that rendered the ballistic table technically inaccurate, but restored the tank's primary capacity to inflict violence. Finally, the final drive differential, the complex gearing assembly that translated engine power to the tracks, was reduced to a bucket of metallic teeth by the initial shell hit. This unit was considered non-repairable outside of a base workshop. Jensen, in a stroke of sheer inspired mechanical genius, discovered that a slightly different ratio differential from a completely wrecked earlier model M4A1 hull could be fitted, provided he manually machined 2 replacement mounting shims using a rough grinder and a broken truck axle as raw stock. This was the ultimate violation of the system, jury-rigging the final drive ratio to marry 3 disparate, ruined components into a single, functional, though mechanically heterogeneous, drivetrain. His success was not a miracle. It was the embodiment of the pragmatic, adaptable, and fundamentally self-reliant industrial culture of America, a stark contrast to the rigid, centralized, and brittle German command structure, which permitted zero field modifications to its precious, overly complex weapons. Jensen was the microcosmic distillation of the entire American strategy. When the supply chain was briefly stalled, the ingenuity born of abundance simply created a new link. He wasn't waiting for the next one off the line. He was making one where none should exist, demonstrating that the only part truly irreplaceable in the American war effort was the unflinching technical stubbornness of men like him. Oberleutnant Karl Richter, 22 years old and already an ace in the Heer's armored formations, surveyed the silent, burning wreckage through the narrow optical slit of his Panther AOSFG. The kill was clean, a textbook execution performed at 1,100 meters, the 60-degree slope of the American M-Four Sherman's glacis plate offering no meaningful resistance to the Panther's 75mm KWK-42 cannon. Richter allowed himself a thin, knowing smile. This was the fundamental, unassailable truth of their war, the inherent superiority of the German machine. They could afford to be outnumbered so long as each German crew carried the calculus of loss, the understanding that their single Panther represented the fighting capacity of 6, perhaps 8, American tanks. Richter felt a righteous technical disdain for the enemy's main battle wagon. The Sherman, with its soft silhouette, its high profile, and its short, stubby 75mm gun, was derided by his fellow crews as a Ronson for its tendency to ignite easily, or more colorfully, as a flying milk bottle, due to the harmless trajectory of its smaller rounds against the Panther's massive, sloped armor. His operational philosophy was predicated entirely on this technical differential: stay hidden, engage beyond the enemy's effective range, and convert every sighting into a 10-to-1 kill ratio. This, he believed, was the only way to negate the frightening, almost nonsensical figures of American production. "Let them build 100, he had told his gunner that morning. "We will destroy 10 and break the morale of the other 90. This was the German strategy in microcosm, a desperate, beautiful gamble rooted in technical hubris. That particular M4, the very tank now known as the Bastard, had been one of Richter's many clean kills in that harrowing sector of the Hürtgen. He had watched its track snap and the turret spin wildly before the internal fire claimed it. It was a tactical victory, a small, satisfying deletion from the enemy's roster. Yet even in that moment of triumph, a faint, corrosive dread had begun to set in. It was not the sound of the next American volley that haunted him, but the sheer, rhythmic, industrial absence of hesitation. When Richter's platoon was reduced from 5 tanks to 2, the replacements came weeks later, often requiring complex, centralized rail transport and field maintenance just to make them operational. When the Americans lost 5 tanks, the survivors were simply reinforced, sometimes within 48 hours, by columns of fresh, identically equipped, interchangeable steel. This was the climax at the midpoint of ideology. Richter's technical brilliance, his capacity for long-range, definitive destruction, was immediately revealed as a losing gamble. He was forced to fight a war of selective, surgical engagement, desperately conserving his specialized ammunition and his irreplaceable Maybach engine. He knew that every engagement, even a successful one, chipped away at his Panther's limited operating hours, its finite fuel supply, and its brittle supply chain. He was a champion gladiator in an arena where the enemy could simply field 10,000 more gladiators instantly. The tactical reality was that the American tanks didn't need to be technically superior to the Panther. They only needed to be produced quickly enough and in sufficient numbers to survive the engagement long enough to call in the overwhelming industrial weight of American artillery and air power. The German technical perfection demanded scarcity and a continuous, unsustainable level of skill from every crewman. The American philosophy demanded only the unstoppable momentum of their industrial colossus. Richter, in his turret, may have mocked the enemy's simple radial engine and the high explosive shells that glanced harmlessly off his glasses. But his laughter was already turning into dramatic tension. He was beginning to realize that the sight of a dozen M4s coming through the trees was far more terrifying than the sight of a single, perfectly built German machine. The final awful truth was not that the Panther was technically superior, but that its superiority was irrelevant in the face of the unquantifiable tide. The single Sherman he had knocked out was merely one grain of sand in an endless dune, and his own glorious machine, the product of countless man-hours and scarce European alloys, was merely a target awaiting its inevitable replacement by mathematical inevitability. He might kill 10, but the chilling realization, the true agonizing core of the German defeat, was that for every Sherman he destroyed, 20 more were already on the ocean, and the sheer industrial noise of their arrival was deafening. In the perpetual gloom beneath the shredded canopy of the Hürtgen Forest, Master Sergeant Jensen finally achieved his impossible victory. After 21 days of unforgiving, unauthorized labor, a continuous grinding application of field improvisation and sheer technical will, the M-Four Sherman, the wreck scornfully dubbed the Bastard, coughed to life. It was a triumph achieved through mechanical heresy, a machine Frankenstein together from the salvage of 3 distinct wrecks, its engine block, turret ring, and final drive differential, all non-standard, incompatible components violently coerced into function. The roar of the Continental radial engine, though rougher and less polished than the sound of a factory-fresh unit, was the purest music of defiance. Jensen had wrestled a mechanical cadaver from the grip of death, proving that the ingenuity of the American soldier could, if momentarily, supersede the inexorable logic of the assembly line. It was a singular, intimate human victory, a personal refusal to accept defeat. But the moment of this micro-triumph, the sound of that single resurrected engine, was instantly and brutally swallowed by the deafening scale of the industrial avalanche. The narrative pivots here from the microscopic struggle of one man to the astronomical, overwhelming reality of the war's true foundation: American capacity. While Jensen had spent 21 days performing his desperate, heroic act of salvage, fighting the mud and the cold to restore one single fighting vehicle to the front, the data point that mattered was elsewhere. In those exact 3 weeks, operating far from the mud and the shell fire, the great industrial colossus of the United States had completed, tested, and shipped precisely 708 brand-new Sherman tanks to the European theater of operations. The irony was stark, brutal, and strategically profound. Jensen's incredible act of engineering stubbornness, the ultimate expression of human tenacity, was, in the cold, hard mathematics of logistics, strategically meaningless. The single Sherman he brought back to life was just that. 1. Yet the factory lines in Detroit and elsewhere, operating on 3 shifts a day, 7 days a week, had accomplished his Herculean task every 60 minutes. His desperate salvage was replicated hour after relentless hour by the sheer, cold, inhuman rhythm of the assembly line. This was the moment the core thesis of the conflict was truly proven, the moment the German ace Oberleutnant Richter's momentary perfect victory was utterly drowned. Richter's long-range shell hit, the act of surgical destruction that created the bastard, had merely destroyed a single droplet in a tidal wave. For every 1 unit of materiel the meticulously crafted German Panther was capable of destroying, the American industrial base was capable of replacing a full 25 units. This was the terrifying realization of the unstoppable avalanche doctrine. The American strategy did not require perfection in its machines, only abundance. The Sherman did not need to be superior to the Panther, it only needed to be expendable and instantly replaceable. The entire logistical chain from the raw iron ore mined in Minnesota to the final track links welded in Michigan was optimized not for quality but for quantity and speed of deployment. This meant that the German ace's calculated gamble, his faith in a 10-to-1 kill ratio, was invalidated the moment he pulled the trigger. He might score a decisive victory, but the industrial clock was ticking against him, a loud, overwhelming sound, measured not in seconds, but in the arrival of new, interchangeable, fully fueled steel. The German war effort was a closed system, a pool of finite resources that shrank, with every battle relying on complexity to compensate for its limitations. The American effort was an open system, an inexhaustible river flowing from the industrial heartlands across the vast Atlantic. The sight of the bastard driving out of the repair yard, a mechanical testament to Jensen's defiance, was immediately followed by the sight of endless columns of fresh, identically stamped steel arriving at the railhead, the sheer, overwhelming volume demonstrating that the war was not about tanks, but about tonnage. The American soldier was strapped to a locomotive of industrial power so immense that his enemy could not even comprehend its scale, let alone fight it. Jensen's act was philosophically profound because it showed the grit of the man behind the machine. But the statistical reveal was the chilling, undeniable truth. The single act of rebuilding was drowned by the ceaseless, unapologetic deluge of the next 708 tanks. The true terror was not the explosion that created the wreck, but the factory's utter indifference to it. The sheer volume of steel delivered by the industrial avalanche was merely the visible manifestation of a deeper, more profound asymmetry: the petroleum war. Logistics, in the brutal calculus of the European theater, was destiny, and the fate of every German tank, plane, and truck was sealed not on the battlefield, but in the sterile chemistry labs where they desperately sought to create what America possessed in geologic excess. The German war machine was a testament to scarcity, its very movement dictated by the agonizingly resource-intensive process of Fischer-Tropsch, a complex chemical reaction used to synthesize aviation and motor fuel from coal. This process was a technological marvel born of necessity, yet it was also the Wehrmacht's ultimate choke point. It required enormous energy inputs, vast fixed industrial complexes, and produced a finite, vulnerable supply, meaning that every gallon consumed by a Panther tank was a gallon painfully extracted from a shrinking national reserve. The German High Command was forced to view every kilometer traveled, every flight flown, and every training exercise performed as a direct, irretrievable depletion of their existential lifeblood. Juxtapose this desperate scarcity with the casual, almost criminal abundance of the American supply. The United States possessed, within its own borders, a seemingly unlimited, naturally derived torrent of crude oil, an asset so vast that its deployment was measured not in scarcity, but in speed and volume. The logistical underpinning of the entire European campaign was the relentless, unstoppable procession of T2 oilers, massive, rapid-build tankers crossing the Atlantic, carrying millions of barrels of crude and refined high-octane gasoline. This flow fed not just temporary reserves, but permanent, staggering fuel dumps, engineered to hold reserves in the multi-million-gallon range, acting as vast, sloshing reservoirs of kinetic energy. The most audacious expression of this logistical supremacy was Pluto, the pipeline under the ocean. This engineering marvel, a secret, flexible pipeline stretched across the bed of the English Channel, was capable of pumping over 1 million gallons of fuel daily directly from Britain to the armies advancing across France. It was a tangible, physical manifestation of America's refusal to allow tactical decisions to be dictated by the enemy's capacity for interdiction. This unimaginable, almost liquid wealth gave the American military a decisive, unapologetic strategic advantage: untethered tactical decisions. Where the German Luftwaffe was forced to ground its jet prototypes and elite piston engine fighters to conserve fuel for a single, desperate counterattack, the American Air Force operated on a principle of profligacy. The legendary P-51 Mustang fighters, operating with massive drop tanks, could provide unlimited long-range bomber escorts, circling over deep German territory for hours, consuming thousands of gallons of high-octane fuel with an impunity that must have seemed like outright madness to the German pilots. The doctrine was simple. If a flight required 300 gallons of fuel to achieve the objective, and an extra 1,000 gallons was wasted in achieving absolute air superiority, the 1,000 gallons were expendable. The sheer volume allowed tactical wastefulness to become a fundamental strategic asset. The German military was constantly at the mercy of their dwindling fuel reserves. Their tanks were forced to conserve every drop. Their panzer divisions slowed, often stalled, awaiting the next meager train shipment. Their operational plans were not about maneuver, but about fuel budget. The American military, conversely, was limited only by its speed in deploying the excess. The goal was not conservation, but consumption. Push the fuel forward, utilize the maximum possible kinetic energy, and drown the enemy in a deluge of steel and unstoppable movement. The abundance of petroleum meant that the M-Four Sherman, the tankmaster Sergeant Jensen had painstakingly rebuilt, could be driven full throttle, thrown into every fight, and, if knocked out, immediately replaced by a fresh, fully fueled machine, with the certainty that the next one, and the one after that, were already being pumped through the pipelines or shipped across the ocean. The true logistical genius was not efficiency. It was the ability to wage a war of complete and utter petroleum waste, a strategy that no European power, let alone the besieged German Reich, could ever hope to match. This industrial differential turned the vast supply of oil into the true, invisible mathematics of destruction. The mechanical miracle of the bastard was afforded no parade, no accolades beyond a weary salute from the motor pool sergeant who handed Master Sergeant Jensen a new clip of ammunition and a fresh stack of regulation forms, which Jensen promptly tossed into the mud. The tank, a grotesque Frankenstein of salvaged components, was operational, yet it remained an unholy mixture of 3 dead machines, its rough, non-standard final drive singing a louder, more discordant song than any of its comrades. It was immediately thrust back into the brutal, unforgiving grind of the front lines, its very presence a defiance of the logistics manual. This was the ultimate test of tenacity, the moment the philosophical argument of American industrial capacity was translated into the visceral reality of combat. The bastard was not expected to win a glorious duel. It was expected to absorb punishment and simply be there. The inevitable confrontation came not with the dramatic long-range crack of a Panther's gun, but with the insidious close-quarters terror of a concealed anti-tank gun, a Pak-40, hiding deep within the tree line. The bastard was advancing across a fire-swept clearing, providing suppressing fire, when the German shell struck. It was not a catastrophic armor-penetrating hit, but a brutal, deflecting blow against the right-side bogie assembly, the very area that had crippled the tank weeks prior. The thick steel ricocheted the round away, but the kinetic energy was devastating. The impact shattered 3 return rollers, twisted the main suspension volute into a useless spiral of metal, and jammed the track against the fender. The tank ground to an immediate, agonizing halt, listing badly, a sudden, conspicuous monument to its own vulnerability. Smoke poured from the damaged suspension, the internal klaxon blared, and the crew, trained by the hard-won doctrine of abandon and replace, prepared to egress. This was the critical juncture, the moment where the two opposing industrial philosophies clashed in the heat of battle. The German philosophy, embodied by the Panther, fixated on initial survivability. The Panther's thick, sloped glacis plate was designed to deflect the 75mm rounds of the Sherman, allowing it to dominate the battlefield from a position of relative invulnerability. But once critically damaged, a thrown track, a damaged engine, the Panther was immediately rendered an immovable, high-value liability, often requiring specialized recovery vehicles and weeks of depot maintenance, due to its complex, non-standardized components. The German machine was designed to win a battle decisively and flawlessly. The American machine, the much-maligned Sherman, was designed for a different, more enduring purpose: to win a war of attrition. It may have possessed thinner armor, but its design emphasized redundancy and repairability. When the bastard was hit, the crew immediately began the standard procedure, preparing to call in the covering fire necessary for them to bail out and transfer to a replacement vehicle that was already being prepared 3 miles behind the lines. But Sergeant Jensen, now acting as the crew's technical conscience, flatly refused the evacuation order. "That track's just jammed, not broken," he shouted through the interphone, his voice hoarse with metallic certainty. His philosophy, forged in the mud of the salvage yard, was one of technical refusal. Jensen understood that the American industrial premise was not just about the volume of new production, but about the speed of recirculation. The tank's very survival, its ability to withstand a non-penetrating but crippling blow and retain its structural integrity, was a testament to its American-made redundancy. Within minutes, under covering smoke and the furious crackle of their .50 caliber machine gun, Jensen and his driver were out on the track. They used a large hammer and a salvaged piece of angle iron to physically bash the jammed track free of the twisted fender, temporarily bypassing the destroyed return rollers. The solution was crude, violent, and utterly unauthorized, yet within a mere 30 minutes, an impossibly short time for a tracked vehicle repair under fire, the bastard was moving again, sputtering, complaining, but still advancing. The tank could limp, it could crawl, but it was still in the fight. This was the central idea made manifest. The Panther was a finely tuned instrument designed for perfection, prone to catastrophic failure when stressed. The Sherman was a robust, over-engineered engine of war, designed to absorb damage, accept abuse, and be violently coerced back into function by a mechanic with a wrench and a stubborn mind. It was this focus on survivability and quick field maintenance, born entirely from an industrial capacity that could produce unlimited spare tracks, volute springs, and engine parts, that gave the American machine its true, unquantifiable advantage. The German machine was engineered for the glory of a singular, perfect engagement. The American machine, exemplified by the ugly, cobbled-together defiance of the bastard, was designed to endure the unglamorous, brutalizing necessity of total war of attrition. The battle fought by Master Sergeant Jensen in the mud of the Hürtgen was merely the ground-level skirmish in a far grander conflict, one waged with the overwhelming, unapologetic industrial output of the American economy. The air war, conducted at 25,000 feet above the scarred landscape, was not a separate theater, but the ultimate, most devastating expression of the industrial thesis. The German capacity for technical brilliance against the American capacity for total crushing volume. Just as the M-Four Sherman was derided for its simplicity, yet prized for its abundance and repairability, its aerial counterparts, the B-17 Flying Fortress and the B-24 Liberator, were massive, somewhat inelegant, and slow, yet possessed a devastating, crucial characteristic: the sheer statistical impossibility of shooting them all down. This was the core tenet of the American bombing campaign. The yuppie mathematics of replacement, a direct echo of the ground war philosophy. The B-17, designed to absorb extraordinary punishment and continue flying, was built not for speed or stealth, but for redundancy. It was an airborne Sherman, its relatively corpulent frame bristling with up to 1350 caliber machine guns, a weapon platform that traded the sleek lines of its German adversaries for the brutal security of overwhelming defensive fire. The unapologetic military business history of these aircraft was simple. They were designed to be built quickly, deployed in massive daylight formations known as the combat box, and to deliver staggering volumes of high-explosive ordnance with a relentless clockwork precision that shattered the delicate German industrial ecosystem. Consider the German fighter pilots, the aces like Adolf Galland, who flew the sleek, technically advanced Messerschmitt Me 109 and Focke-Wulf 190. They were highly trained, skilled men, capable of achieving incredible personal kill ratios. Yet the data reveals their defeat was not a failure of courage, but a failure of industrial arithmetic. They were facing not individual planes, but the statistical impossibility of shooting down an entire sky full of targets. For every one German fighter shot down by the defensive fire of the American bomber stream, the factory lines ensured that 3 new American bombers entered the theater from plants like Willow Run. This relentless, crushing mathematics meant that even a perfect German defense was simply a delaying action, consuming irreplaceable fuel and airframes while the American production curve continued its inexorable upward climb. The true strategic weight of these hammers from heaven fell upon the most brittle links in the German industrial chain, chiefly the synthetic fuel and component manufacturing centers. The B-17 formations, protected by the fuel-rich P-51 Mustangs, delivered an average of 15,000 tons of ordnance per month by mid-1944. This was focused destruction, a continuous, systematic dismantling of the Fischer-Tropsch plants that provided the Wehrmacht with its lifeblood. The destruction of these synthetic fuel complexes meant that every gallon of petroleum became a scarcity, directly impacting Oberleutnant Richter's ability to move his superior Panther, directly strangling the supply lines that were already thin. For every single, meticulously engineered German engine block produced, 10 American bombs were aimed at the factory gate or the crucial railway junction leading to it. The war in the air, therefore, was not merely a battle. It was the mechanism by which American industrial capacity was projected directly onto the German economy. The sheer, overwhelming number of American sorties, the constant grinding presence of the formations, forced the German Air Force into a continuous draining state of defense, forcing the expenditure of scarce, high-octane fuel and highly trained personnel. The technological brilliance of the German war machine, the very foundation of their strategy, was simply beaten into submission by the relentless, crushing volume of output produced by the American industrial colossus. The defeat of the Luftwaffe was final proof that in this conflict the deciding factor was not the quality of the individual weapon, but the capacity of the nation to drown the enemy in an unapologetic deluge of steel and lead. The fate of the bastard in the mud was inextricably linked to the fate of the synthetic fuel plants being pulverized 25,000 feet above. The mud had long ceased to be the primary enemy for Oberleutnant Karl Richter. The real adversary was the crushing, quiet tyranny of the subtraction sign. It was January 1945, and the German defense had devolved from a calculated defense to a desperate ideological struggle against the logistical void. Richter's once pristine Panther AOSFG, the apex predator of the battlefield, was now a wounded beast, its sophisticated Maybach HL-230 engine wheezing, its life halved not by enemy fire, but by the unavoidable corrosion of poor maintenance and the reliance on lower-grade synthetic lubricants. Every complex, tightly toleranced German component, the very source of its initial superiority, had become a liability. The intricate torsion bar suspension was perpetually seizing for lack of specialized attention, and a simple malfunction in the multi-disc steering clutch required days to fix, days the Wehrmacht simply did not have. Richter was operating with his fuel gauge hovering near empty, his operational budget measured not in kilometers but in single-digit liters. His 75mm ammunition was rigorously rationed, forcing him to hold fire, abandoning the technical advantage of long-range engagement. The technical hubris that had fueled his early victories had curdled into a bitter, somber recognition of fate. He wasn't fighting tanks anymore, he was fighting the entire American economy. The ultimate confrontation was not a glorious duel, but a tactical execution, an inevitable consequence of the mathematics of tenacity finally overwhelming the calculus of loss. Rounding a final shell-cratered ridge, Richter did not encounter a single vulnerable M4. He encountered a swarm. There were 7, perhaps 8 of them. The sight blurring into an overwhelming, continuous wall of steel, their silhouettes high, ugly, and numerous. It was a statistical impossibility made manifest, a relentless tide of interchangeable, expendable machines that no single ace, however brilliant, could hope to stem. Somewhere among them, lurking with its mismatched parts and its stubborn refusal to die, may well have been the bastard, a fittingly ugly metaphor for the whole American effort. Richter sighted a target, but before his gunner could traverse the long KWK-42 cannon, the sheer volume of incoming fire was devastating. It was not a single decisive blow, but an avalanche of steel and lead from multiple directions. 75mm, 76mm, and 50 caliber rounds impacting the Panther's sides and mantlet like a continuous thunderclap. The individual shells did not matter. The volume did. The thin, vertical side armor, always the Panther's weak point, was breached. The interior was immediately consumed by fire, the highly specialized machinery violently incinerated. Richter's defeat was a quiet, inevitable footnote to the larger industrial narrative. His Panther, the product of countless hours of scarce, specialized labor, was gone, transformed into another burning piece of wreckage on the road, while the surrounding American Shermans simply adjusted their course and continued their advance, already certain of their fuel and ammunition resupply. This moment defined the true end of the line. The war was not lost because the German soldier lacked will, but because the German industrial system was too complex, too brittle, and too finite. The German strategy was designed to win in 1940. It was structurally incapable of winning the global industrial warfare of 1944. The moment the American industrial base was fully mobilized, the moment the Willow Run plant began producing a bomber every hour, and the Texas oil fields began pouring their contents into the Atlantic, the war became an exercise in statistical validation. Richter's technical brilliance, his belief in quality over quantity, was revealed as a magnificent, doomed anachronism. His fate was sealed not by the enemy's superior skill, but by the relentless, crushing reality of their superior, overwhelming industrial system, a system that treated his magnificent Panther as merely another obstacle to be drowned in an unapologetic deluge of abundance. The physical demise of the Panther was the inevitable consequence of its own technical sophistication when pitted against the limitless, vulgar, and unstoppable logistical simplicity of the American Colossus. The M-Four Sherman, the mechanical Frankenstein christened the Bastard, survived the final bitter months of the war, a monument to the unyielding tenacity of American improvisation and the stubborn refusal of Master Sergeant Earl Jensen to submit to the logic of abandonment. Its mismatched components, the salvaged crankcase, the unauthorized final drive, the cobbled-together suspension, were a physical testament not to battlefield heroism, but to the deep pragmatic engineering ingenuity that flowed from an industrial culture of overwhelming confidence. The Bastard was ugly, noisy, and inefficient. Yet it endured, ultimately proving that the only thing more powerful than a perfect weapon was an endless supply of merely good enough ones, backed by a will to keep them moving forward. The final profound meaning of Jensen's impossible job was not the salvation of one tank, but the philosophical assertion that the American logistical tail was a living, breathing entity that could repair its own wounds and defy the very concept of irrecoverable loss. But the final terrifying truth of the industrial war was revealed not in the combat logs, but in the statistical aftermath. The cessation of hostilities across Europe and the Pacific did not bring a halt to the relentless flow of American output. It merely shifted its purpose from production to disposal. The German military machine, predicated on its scarce, sophisticated designs, had been utterly consumed in the 4 years of conflict, its total output a finite, measurable quantity of steel and aluminum. The American military, however, faced a problem of abundance so great it was incomprehensible, a logistical headache of unprecedented astronomical scale. The data point that truly hammers home the thesis is chillingly unambiguous, the final crushing calculation in the mathematics of destruction. Following the cessation of fighting, the United States military, after retaining what was necessary for the standing force and distributing aid, was forced to confront the unmanageable excess of its own production. Vast mountains of surplus materiel were created, fields stretching to the horizon where perfectly functional brand-new equipment was amassed for scrapping. The final, rhetorical and statistical truth is this. The United States military was ultimately forced to scrap or dispose of more aircraft, more tanks, more ships, and more ammunition than the entire German military manufactured and utilized during the entirety of World War II. Consider the scale. Thousands of Liberty ships, built on assembly lines that ran 24 hours a day, were sunk in deep water or sold for scrap for pennies on the dollar. Tens of thousands of B-17 and B-24 bombers, the very hammers from heaven that had pulverized the German industrial base, were flown to desert graveyards and rendered into raw aluminum. The sheer deliberate waste of this final disposition, the conscious decision to destroy a wealth of materiel that exceeded the total productive capacity of their primary enemy, is the ultimate, undeniable proof of the war's underlying cause. The real weapon was never the M-Four Sherman, nor the B-17, nor the Liberty ship. The real weapon was the vast, limitless, and unquantifiable industrial capacity of the United States, an economic engine so powerful that its overflow alone was greater than the total focused effort of the German Reich. This overwhelming fact rewrites the narrative of victory. The outcome of the Second World War was not determined by a miracle of courage, nor a singular flash of genius on the part of any general. It was not a tale of the underdog's triumph. It was, rather, an act of pure, relentless, and unapologetic industrial mathematics. The German military was defeated the moment the American factory floor was fully engaged. Its victory guaranteed by the certainty that it could always replace 100 items for every 10 the enemy destroyed, and still have enough left over to casually discard the remainder. The war was a contest between the finite, high-quality output of scarcity and the limitless, overwhelming volume of abundance, and abundance won, not through elegance or chance, but through the sheer brute force application of steel, oil, and the unstoppable output of the American assembly line. The single resurrected Sherman and the millions of tons of scrapped excess tell the same story. The war was an industrial execution,